Bunkers, the ultimate fortresses, built to withstand anything the modern battlefield can throw at them. Nuclear blasts, airstrikes, relentless artillery, no problem. For decades, these underground strongholds seemed impenetrable, until now. Countries like Iran, North Korea, and China have spent billions turning the Earth into their shield, confident that no weapon could touch them. But what if that confidence is misplaced? Enter the bunker buster. These terrifying bombs don't just hit their targets, they annihilate them. They tear through reinforced concrete and steel like a hot knife through butter, making even the deepest bunkers seem like sandcastles against a tidal wave. In this video, we're breaking down the evolution of these unstoppable weapons, from the groundbreaking designs of World War II to modern monsters like the GBU-57, capable of ripping through 200 feet of concrete. And here's the big question: can they be stopped?
Alright, one of the reasons I'm interested in doing this video is recently, after the bombing in Iran, the mainstream media were like using the word obliteration was an exaggeration of what actually happened in Fordow, Natanz, and Isfahan in Iran. But it's not making sense to me. Okay, before I say it's not making sense to me, I would like you, let's just look at the characteristics of this bomb and then compare it with the possibility that dropping 12 of it in a single location, 12 dropping 12 of these stuffs in a single location. I don't think using the word obliteration was an exaggeration, not in the slightest.
Is there any defense against a weapon designed to turn fortresses into rubble? Can nations like Iran, with their cutting-edge concrete, stand a chance? Or are these bunker busters truly unstoppable? Let's find out. As a US Air Force veteran aptly puts it, the only defense against a bunker buster is to be somewhere else. However, there are ways to stop, or at least attempt to stop, a bunker-busting bomb before it reaches its intended target. But to understand why this is the only way forward, we need to dive into the science of these massive weapons. It's like trying to outsmart a heavyweight boxer. Understanding their moves might just give you the edge you need to avoid the knockout punch. However, there's no understanding bunker buster bombs without exploring the other side of the equation, the evolution of bunkers themselves. After all, these two entities have been locked in a long-standing tug-of-war where the stakes couldn't be higher. Each time one side gains the upper hand, the other quickly adapts, leading to a relentless cycle of innovation and counter-innovation. And this video is all about that battle. Bunkers versus bunker buster bombs, high-tech concrete versus precision explosives, fortification versus annihilation. Who will win in the end? For now, and in the foreseeable future, the bunker buster bombs are leading the race, but naturally, bunkers were the first to enter the scene. The use of bunkers began in World War I, where they served as essential shelters for soldiers facing the horrors of trench warfare. Constructed from mud and sandbags, these rudimentary fortifications quickly evolved, paving the way for more advanced designs during World War II and beyond. As aerial bombardments became a reality, nations started to dig deeper, reinforcing their shelters with concrete steel to withstand the onslaught from above. Between the World Wars, the French and Germans built extensive fortifications known as the Maginot Line and the Siegfried Line, respectively, featuring reinforced concrete to withstand aerial and artillery attacks. The Germans also built many bunker fortifications along the infamous Atlantic Wall. World War II was also when the first attempts to create bombs capable of penetrating bunkers began.
I didn't even know that something like this existed until recently. Honestly speaking, I was like, am I that ignorant? Like, something this massive.
After all, traditional bombs were all but helpless against these fortified structures that had become increasingly prevalent on the battlefield. When a conventional bomb drops, most of its energy dissipates into the air, leaving the concrete structure mostly intact. The impact creates a shockwave and might even create a gaping hole, but it simply isn't enough to breach the thick concrete wall, as the surrounding concrete will absorb some of the bomb's kinetic energy.
Yeah, and I think that's why it's also designed to have a very sharp mouth, because when you're dropping something from that high, you expect it to have more like a focused impact, so that whatever it touches at that point of impact, the kinetic energy can just break through it and then do the damage within, not on the outside, because when it explodes on the outside, the energy spreads across in the air, but when it's able to penetrate and then explode within, then it creates gaps. So when you drop like two of it. The first penetrates, breaks the earth, then another penetrates. It's easier for the second one to even penetrate and go deeper. So when you drop 12 of them in a single location, that's obliteration. That is it. I don't think there's any chance that that facility still survived. I don't think there's a single chance for it. It's possible that they might have moved some of the enriched uranium. It's possible, but I think the goal was to stop further enrichment, to destroy the facility. If you decide to attack the already purified uranium, they will simply go and get another uranium and purify it. But when you destroy the machine itself, I think that makes sense. It makes a whole lot of sense.
Blowing it down. The bomb needs to break through the concrete and explode inside to do real damage. Now, concrete might be strong under compression, but it's actually quite brittle when stretched. This makes it less effective against high-velocity impacts. Professor Phil Purnell, a concrete technology expert, puts it bluntly: concrete is inherently brittle. It's good at being squashed, not being stretched. And that's its major flaw. It cracks and crumbles under pressure, creating vulnerabilities. Vulnerabilities that the British exploited to create the Tallboy bomb and subsequently the Grand Slam monster. Revolutionary designs that changed the game in World War II. The Tallboy and the Grand Slam effectively turned the ground beneath fortified targets into a quaking mess. That's why they were also often referred to as earthquake bombs. It goes without saying that both of these bombs were engineered for destruction. Weighing in at 5 tons, the Tallboy had a streamlined design that allowed it to exceed speeds of 750 miles per hour when dropped from 18,000 feet. This aerodynamic structure was crucial.
These are the early bombs. The early ones dropped for 18,000 and weighing that little, like 2,400 pounds. This current one, the GBU-57, weighs 30,000 pounds. That's about I think 13,000 kg, yeah, and dropped from a height of 30,000 feet.
It wasn't just about falling fast. The design featured offset fins that caused the bomb to spin as it descended, enhancing stability and accuracy while making it less likely to be deflected by air resistance. As for the Grand Slam, its name does it justice. Weighing in at a staggering 10 tons, this bomb was an engineering marvel designed for ultimate penetration. It could puncture as much as 20 feet of reinforced concrete, targeting the very core of enemy fortifications. The bomb's casing was crafted from a robust steel alloy of chrome molybdenum, specifically chosen for its strength and resilience. In order to survive the immense forces at impact and achieve maximum penetration, the design had to withstand the brutal conditions of a near supersonic descent. However, even with these impressive specifications, the reality of aerial bombing was fraught with challenges. Some of these massive bombs broke apart on impact, which wasn't entirely unexpected given their sheer weight and the design compromises necessary for achieving such mass and speed. Basically, the shape of the bombs was optimized for falling, not for punching through solid barriers, and this posed significant risks during deployment. Still, both the Tallboy and Grand Slam demonstrated their prowess during World War II. For instance, 2 Grand Slams penetrated the 15-foot reinforced concrete roofs of the Valentin U-boat pens at Farge, showing the incredible destructive potential of these bombs. At the same time, the shortcomings of these bombs made weapons developers look for new solutions. And the so-called Disney bomb was created. Officially, this bomb was known as the 4,500-pound concrete-piercing rocket-assisted bomb, and it was the brainchild of Royal Navy Captain Edward Terrell.
What makes this the GBU-57? Or these recent, or the recent bunker busters, what makes them unique is the ability to also be precise. Like, they have a GPU guiding unit, a GPS guiding unit. So sometimes, I think the GBU-57 has a laser also. So it's a combination of 2 guiding units, a laser unit and a GPS guiding unit. So there's no way it's possible to miss a target, but the chances are very, very minimal because there's something like a foolproof. If this one fails, the other one goes. So the accuracy is very, 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 very.
His primary vision was to create a new weapon that could achieve much higher terminal velocities than the free-falling Tallboy or Grand Slam. Utilizing the principles of Newton's approximation for impact depth and Young's equation, Terrell designed a bomb that was about 16 feet long and 11 inches wide. Its sleek, long, and thin construction was pivotal, as it meant the bomb could focus all its kinetic energy onto a small point.
Yeah, that's exactly what I said. It needs to, for something that huge, like weighing about 2,400 kg, to be that tiny and long, like the breadth is not so wide, just a little breadth, and then just long, not too long though, and then with a sharp mouth, it can be able to penetrate anything. It will be very, very easy to penetrate anything. Just like it said, it would be like using a knife to slice through butter. Yes, I think that's very, very accurate. That's very, very accurate.
Think of it as a dart hitting a target rather than a boulder rolling downhill. The Disney bomb contained over 500 pounds of explosives but weighed a total of 4,500 pounds, as its official name suggests. This ratio allowed it to maintain a powerful punch while being significantly lighter than its predecessors. To achieve maximum velocity, 19 3-inch rocket tubes were attached to the bomb's rear. These rockets were timed to ignite 30 seconds after the bomb was released, propelling it to an astonishing 990 miles per hour.
So, not just are these bombs falling under gravity, they are not just falling under gravity, they are also flying on their own. Like, they are all literally increasing their own speed, because falling under gravity might not be enough to get to that 60 feet of concrete, to penetrate 60 feet of concrete. So they needed to give an extra acceleration to themselves. It's automatic, like gravity plus speed. I'm actually having a hard time trying to understand why the media is trying to make a mess or trying to oversimplify what actually went down in Iran. It's not good for Iran. It's not good for anybody. Like, this kind of Iran is already prone to earthquakes. With this kind of stuff, I'm not a geologist, but this kind of thing that goes very deep, 60 feet into the soil and explodes within, in an earthquake-prone region, it will make them more earthquake-prone because it's causing a lot of vibration within. Okay, there's, for context, so that you understand what's actually going on with the images you're seeing. The image of before and after the explosion that we are seeing are from satellites that are thousands of miles away. But you need to understand that for that camera, for the satellite camera to be able to pick up a change on the soil texture after an explosion that happened 60 feet or let's say 200 feet, because that's a rocky place, so let's say 60 feet. 60 feet inside the soil, the bomb didn't explode on the surface. It penetrated 60 feet within and exploded 60 feet into the soil. And from 60 feet, the surface soil was able to experience changes. Something that happened, an explosion that happened 60 feet into the soil. The surface soil experienced changes that could be captured by a camera that is miles away. That is like using your phone camera to capture something that is so far away that, come on, man. The mainstream media is doing itself a very big hand, because Iran owning a nuclear weapon is not good for anybody either. Because for you to own a nuclear weapon, you have to be responsible, at least not shouting death to America, death to Israel, and then expect the people you are shouting death for to just keep quiet and allow you to do your thing.
Which translates to Mach 1.29. Though the British designed this bomb, the Americans were the ones to ultimately deploy it. The US dropped 158 Disney bombs from B-17 Flying Fortress heavy bombers during the last months of the war. However, it was the tests after the war that truly revealed the destructive capabilities of this bomb. A single Disney bomb could penetrate almost 15 feet of reinforced concrete at the Valentin U-boat bunker, a major German submarine construction and repair facility located near Bremen, Germany. The bomb didn't just breach the roof of the bunker, it blasted through the 3-meter concrete floor below and ended up in the sand beneath. The lighter, slimmer design also meant that aircraft could carry more Disney bombs compared to a single tallboy. However, precision was still a significant challenge. The bombs lacked a guidance system and had to be dropped from a predetermined height of around 20,000 feet. This freefall lasted about 30 seconds. At 5,000 feet, the rockets ignited, expelling the tail section and adding 300 feet per second to the bomb's speed. This brought the final impact speed to 1,450 feet per second. But even with their revolutionary designs, the Disney bombs were still not foolproof. Without a guidance system, they were effectively unguided missiles that relied on precise calculations regarding height, distance, and speed during deployment. While they marked a significant advancement in bomb technology, the true evolution of the bunker-busting munitions came in the decades following World War II. During Operation Desert Storm in 1991, the US faced a pressing issue. The Iraqi command bunkers were buried deep underground and reinforced with several feet of concrete. As a result, the existing 2,000-pound bunker busters were ineffective against these formidable structures. So the US Air Force urgently needed a solution that could penetrate these hardened defenses. Why urgently? Well, because the ongoing conflict demanded immediate action to neutralize the enemy's command capabilities. Otherwise, the US risked prolonging the war and allowing Iraqi forces to regroup and mount a stronger defense. In response to this critical need, the Guided Bomb Unit 28, or GBU-28 for short, was developed at breakneck speed. This innovative bomb measured an impressive 19 feet, giving it the necessary mass to ensure effective penetration. Weighing in at 5,000 pounds, it became one of the heaviest precision-guided munitions of its time, demonstrating the commitment to overcoming the formidable defenses posed by Iraqi command bunkers.
These bombs are actually very, very heavy. Like the GBU-57 that were used in Iran weighs 13,600 kg. That's about 30,000 pounds. You know what 30,000 pounds is? 30,000 pounds is like the weight of 2 adult male elephants, African elephants. 2. The weight of 2, that's one bomb. That's for you to understand the context. 30,000 pounds. The 12 of it dropped in a single location from 33,000 feet. There's no obliteration is not an exaggeration. It's not even in the slightest. I don't think anything came out from that place. Not possible.
Constructed from a modified 8-inch artillery barrel with a diameter of 14.5 inches, the bomb's casing provided exceptional durability and strength, vital for withstanding the immense forces encountered during deployment and impact. Inside, the GBU-28 contained 675 pounds of tritonal explosive, a powerful combination of 80% TNT and 20% aluminium powder, which enhanced the bomb's lethality and made it approximately 18% more powerful than conventional TNT alone.
This bomb used TNT. GBU-28 used TNT. So the current one is actually much more later, because it's made with a PBX, polymer binded explosive, PBX 114. So PBX 114 is like an upgraded form of TNT. So the GBU-57 is like twice as powerful as this, or if not more.
With these specs, the following sentence shouldn't come as a surprise. The GBU-28 was designed for serious impact. The bomb was capable of penetrating up to 20 feet of reinforced concrete and reaching depths of 100 feet into
this
the
one
air.
can penetrate 20 feet, but the GBU-57 can go as deep as 60 feet. So it makes sense. It makes sense that they are using a stronger one that they used before.
Reaching depths of 100 feet into the earth. This allowed the US forces to target and neutralize previously invulnerable bunkers. And the best part? The GBU-28 was equipped with a state-of-the-art laser guidance assembly, so it could home in on targets illuminated by ground spotters or aircraft, with the bomb's fins providing precise steering during its descent. No more maths, just a laser focus on destruction. Remarkably, a bomb with these qualities was developed in just 28 days. On February 27, 1991, 2 operational GBU-28 bombs were delivered by F-111 Aardvark combat jets during a critical mission. While one bomb missed its target, the other made a direct hit on a heavily fortified Iraqi bunker, with smoke coming from the entrance signaling a successful breach. This pivotal moment not only demonstrated the GBU-28's capabilities, but also marked a turning point in the conflict. The Iraqi command was left in shambles. Within 2 days, faced with the reality of their compromised positions, Iraqi forces surrendered, marking a decisive end to their operational advantage. This event alone made the GBU-28 a game-changer, a weapon that would reshape military tactics moving forward. Well, in the late 2000s, rumors began circulating about an Iranian bunker that had been struck by a bunker-buster bomb. But instead of detonating and penetrating the reinforced concrete, the bomb became embedded in the construction's surface. If the rumors are to be believed, UHPC had just shrugged off the bomb like it was nothing. Naturally, this worrisome development sent shockwaves through military circles in the US. The US's response? A new bunker-buster bomb, of course. Meet the GBU-57 Massive Ordnance Penetrator, MOP, a truly monstrous piece of military engineering. Developed after the US noted the decreasing efficiency of earlier bunker busters, this weapon was designed to tackle the hardest, deepest targets that traditional munitions simply couldn't reach. Weighing in at 30,000 pounds and stretching a massive 20 feet long, the GBU-57 is a heavyweight in every sense of the word. Its purpose? To penetrate up to 200 feet of earth or 60 feet of ultra-reinforced concrete. This is possible thanks to its incredible construction. The bomb's casing is made from Eglin steel, a highly durable, low-cost alloy that offers exceptional strength. With a tensile strength of 10,000 pounds per square inch, more than 6 times the strength of construction-grade steel and over 2.5 times that of steel used for artillery barrels, the GBU-57 can withstand the immense pressure of boring through the hardest materials before unleashing its
This is also one of the things that makes the recent explosives, unlike early explosives like dynamite that are very, very unstable, like any slightest change in temperature, friction, it detonates on its own. But these explosives are very, very, very much stable. Like they can withstand the friction and shock of striking on a rock and running through that distance, about 60 feet. That's an evidence that we are really, really going towards mass destruction, because we keep on building things that will essentially make sure that we kill ourselves within the shortest time frame.
Payload. Speaking of payloads, the MOP carries a staggering 2.4 tons of explosives packed into a 6,000-pound warhead. The bomb is guided with GPS precision, using lattice-type fins to ensure it hits its target with pinpoint accuracy. Given its enormous size and weight, the B-2 Spirit stealth bomber is currently the only aircraft in the US arsenal capable of carrying the GBU-57. Each B-2 can carry 2 of these 30,000-pound bombs, and they have been specifically retrofitted for this purpose. With all this in mind, it shouldn't be surprising that the US has spent more than $300 million on 20 of these bombs, each costing a mind-blowing $15 million per unit.
One of these bombs cost $50 million. And you think Donald Trump would waste $300 million? $300 million. Wow. It's not possible, man. It's not possible. Something that's just too impossible that you see through the lies of the media. I don't know why the media is trying to oversimplify the whole thing, and probably I think they're making a joke of it. Making a joke of it is not good for anybody. It's not good for Iran. It's not good for America. I mean, they just wasted $300 million. Well, I call it a waste, but you can say that it's a transactional waste. You are spending to make sure that you are safe, you are safeguarding yourself, but $300 million on a bomb. You know, I mean, $300 million can do a whole lot of things for the poor people in America. I'm not American though, but then $300 million is way, way high And it further solidifies my claim that America wouldn't just waste $300 million just like that. Yeah. So saying that the target was missed or that there wasn't enough damage or waiting for battle assessment report or whatever. At this point, you don't need a battle assessment. We don't need any battle assessment because 12 of these, we've seen the data for this bomb. 30,000 pounds, about 5,300 kg of PPX 114. That's explosive, falling from 33,000 feet with an explosive power of about 13.6 billion joules. That's explosive energy. No, 13 billion joules of energy released from a bomb with a kinetic energy of about 1.3 billion joules. Nothing is escaping. And you drop about 12 of them in a single location. 12 times 13.5 billion. Nothing is, not even a single pin is coming out unless the target was missed. But obviously the target was not missed because that's not the argument. No wonder, just like I said before, the bomb explodes, detonates within the earth at 60 feet. So something that explodes at 60 feet and the soil above felt a change, a kind of change that is a camera from a satellite could picture. The damage is enormous. Using the term obliterated was not an exaggeration, like seriously. That's complete obliteration. The only thing that would survive are the atoms within, because the atoms within the earth will survive obviously, but Fordow is cooked. Like seriously, Anyway, if you like the analysis, just subscribe and I'll see you in the next video.